Okay, we are from Group 3. We present our project on scheduling algorithm. So our team consists of Daniel, Iqmal Hakim, me, myself, and Muhammad Sharaf. So Daniel will explain about um, shortest job next (SJN). Iqmal will talk about um, round robin. Me myself, I will talk about first come first serve, and Muhammad Sharaf will talk about uh, SRT. So this project is carried out to evaluate all all four process scheduling algorithm and identify the suitable algorithm for the job list supplied by the client. So I will talk about first come first serve. As we all know, first come first serve is operating system scheduling algorithm that automatically execute queue requests and process in order of their arrival. It is the easiest and simplest CPU scheduling algorithm. So this is the job list that we need to compute, and then this is my C++ coding that I have done to complete the scheduling algorithm. So after the execution of the program, here I find that the waiting time is 677 for the waiting time, and the turnaround time average is 724. So here is the flowchart. When the job is need to be running, it will be in ready state, and we assume that all the job has been in the ready state. So here they will compute based on the CPU or IO cycle, and if the if the execution is complete and it is true, the process will be end, while if there is still the cycle, then it will be in the waiting turn again. So here is my graph, and I think that's all from me. I will hand over the presentation to Iqmal Hakim for the round robin.
Hello, my name is Kamal Kim, and I will present about the round robin scheduling. So, as a summary for the round robin scheduling, it is one of the algorithms employed by the process and network schedulers in computing. The round robin scheduling also uses time slices, or also known as time quantum, so that each process is handled without priority in a cyclic manner. A good algorithm that avoids starvation and is fairly easy to implement, and the name comes from the round robin principle. So this is a flowchart on how it works. To explain in simplicity, when each job got into a queue, it will the process will be selected, uses each time quantum until it expires. If the job is done, then it will terminate. If it is not done, it will go to the queue once again. For the explanation for this, the round robin, it is scheduling uses times quantum in its algorithm, which results in a no priority scheduling. This means that any process that came first will be processed first, similar to the first come first served scheduling. Although it might not work like first come first serve, round robin limits the time for each process that we serve. As an example, process A is scheduled with a time quantum of 10. If another process was also scheduled during that time, process A will be processed until the time quantum given has expired. And when the time quantum expired, the next process will take over the process A will be put into queue, waiting for the other process to finish it in its own time quantum.
My name is Muhammad Sharaf. I will explain about the shortest remaining time. Shortest remaining time (SRT) is a primitive version of shortest job next (SJN). The process with the shortest runtime to be completed is scheduled to run next, including new arrivals. Context switching is applied on SRT. Next, this is the flowchart for the SRT. Next, when the process is at a ready queue, it will start with the shortest arrival time. If there is no context switching to be performed, then it will execute the process. If there is context switching, it will perform context switching before execute. And if the process is not completed yet, it will set to ready queue again and repeat the process. After all the process is complete, then the process will terminate when will produce the SRT. This is the output for the coding, which is for the average turnaround time, we get 106.233, and for average waiting time, 59.81415. That's all. Thank you.
Hi, my name is Daniel, and I'll be talking about the shortest job next. Shortest job next is a process scheduler algorithm that handles the job based on the CPU cycle time or burst time. Shortest job next is a non-preemptive scheduling algorithm that is also most commonly known as shortest job first. It works best when it is used for interactive batch systems. The algorithm mainly schedules the jobs process based on the shortest burst time. Next. And this is the execution of the coding for the shortest job next. As you can see at the enter total number of process, you can select how many jobs you would like to enter. In this case, I put 5. After putting 5, it will then take the inputs for all the jobs. And after that, all the jobs, all the burst time will then be assigned to a temporary array, and that temporary array will be used to calculate the shortest burst time in order to find the next job that is to be scheduled next. And the results that we have gotten from this code is average waiting time is 87.4, and average turnaround time is 137.6. But the Okay, so based on the results that we've gotten from all the 4 scheduler algorithms, FCFS, shortest job next, shortest remaining time, and round robin, we can clearly see in the table on our left that is the results. And I've also made a double bar chart to show which of these scheduler algorithm has the best average waiting time and average turnaround time. And from this, we've concluded that shortest remaining time has the best average waiting time and average turnaround time. Hence, we have decided to go with shortest remaining time for our process scheduler that we will use for the Unimas operating system. And that is all from us. Thank you.